What we're going to do in this video is we're going to talk about theoretical and actual yield and how to calculate percent yield. So what we have to do in these types of problems when we calculate theoretical yield is we have to use stoichiometry. So in this example, imagine that you are a scientist that is working to improve the process in which iron ore is converted into iron. So in your test, you're carrying out this reaction on a small scale, and you're starting with 150 grams of iron 3 oxide. Now, in this iron 3 oxide, that's your limiting reactant. So from this limiting reactant, you want to figure out what the theoretical yield of iron is. And so that's going to be part A. Part B then, we're going to look at the actual yield of what you got in your laboratory test and determine the percent yield. So what we're going to start with is we're going to start with part A. The theoretical yield, that's what it asks you to calculate. So the theoretical yield is based on your stoichiometric calculations. Remember, theoretical is always in grams. So when you're talking about yield, usually you're talking about the mass, which is grams. So what we're going to do is we're going to start with our 150 grams of iron 3 oxide. Now, whenever we have grams, what should we go to? Moles. So we're going to go grams to moles using the molar mass from the periodic table. That gets us to moles of iron 3 oxide. Now the problem wants to know our theoretical yield of just iron. So we look at this balanced equation and we use the mole ratio. For every 1 mole of iron 3 oxide we use, we make 2 moles of iron. And so that's what I'm going to use right here. I'm going to use my mole ratio to go from the iron compound to just the elemental iron. Now, theoretical yield, like I said, is always mass. So once we have moles of iron, we have to go to mass using the molar mass from the periodic table. Now, when we solve this, we get 104.9 grams of iron. However, if we look at our given, it's 150, but we have that decimal after the 150. That means we have 3 significant figures. So what that means is we need to round this to this 4. But since it's 0.9, it's going to be rounded up to 5. So when we round this to 3 significant figures, we get 105 grams of iron. That's our theoretical yield. So theoretically, we should get 105 grams of iron in our laboratory test. However, in part B, it says if the actual yield of iron, so in your test, you only get 87.9 grams of iron. So we have to find our percent yield. So our actual yield is based on our lab. Percent yield is always actual divided by theoretical times 100. Typically your actual is less. Now, if for some reason you have source of error that maybe you didn't dry something off, it might be more, but usually your actual is less. So we take 87.9, we use our unrounded answer. Okay, so we're going to plug our unrounded answer in here. 87.9 divided by 104.9 times 100, because it's our percent yield, gets us 83.8%. So in this laboratory test, we only recovered 83.8% of what we should have.